Shane Brinkman-Davis-Delamore, and this is Code and Optimism, a show where I explore how to solve problems faster with software. Today's topic is code quality metrics. Now, we've been talking about refactorability, also had an episode on code quality. Now I want to focus a little bit on the brass tactics of actually using metrics, because as they say, you can't actually improve anything if you can't measure it. At the top level here, right, we're talking about solving problems faster with software. And within the context of code quality, we're talking about when we have existing software that we want to adapt to solve new problems. So we want to solve problems faster given existing software. And there's really kind of two parts of that, I think. One is adding new capabilities, and how do we add them faster? And that is not what we're talking about today. That is software architecture and good software architecture design. And in this case, we're talking about extensibility, although software architecture does other things as well. So I'm not going to focus too much on extensibility because I want to focus more on whatever your code architecture happens to be. How do you make that code easier to change? So that's code quality. And as I've talked about in the previous episodes, really I think of the term refactorability as the basis and definition of code quality. How easy is it to change your code to meet new and ever-evolving requirements? What does it mean to be able to change code faster? Given that you've got a problem that you need to solve, really I think it comes down to two main things. There's lots of subtopics, but one, you need to be able to understand what code needs to be changed and edited when to accomplish these goals. So you've got a new feature requirement or you've got a bug you need to fix. It needs to be easy to understand what you need to do to the code to achieve your goal. So there's a lot of making the code clear, making the code not too much to understand. You want to have minimal effort to understand what you need to do. And the second part is when you actually go in to do the change, it should require the minimum number of steps. You should be able to touch the minimum number of files. You should touch the minimum number of actual code points. It should be as concise as possible. And when you do those changes, you should be able to know, because it's easy to understand, that you're not breaking other things elsewhere, because other things are well isolated and well separated. Now, what are some metrics? How will we actually maybe measure if we're improving code quality to make it easier to change code faster? And I want to say at this point, I don't have all the answers here. I am very curious to hear from you if you've got additional thoughts about what are the things that make code easier to change in respect to bugs or features or even pivots. Possible metrics, I think there's really two main broad categories. One is the less is more category. The smaller your code is, by definition, there's going to be less to edit. And by definition, there's going to be less to understand. Now, certainly you can have sort of an obfuscation perspective on making the code small, in which case those may not apply. But as long as your code is small and also clear, smaller code is going to be easier to manage. And under that, there might be many ways you might measure the size of your code. And you might think about, on individual functions, how many parameters or how complicated are the inputs and outputs. You might look at a module or a class and see how many functions are on this module or class. And I really kind of like thinking about things as API. So it's really how complicated is the API. The function has an API. A set of functions is an API for a module. You also might think about how many modules there are in general. These are all ways of measuring the code size. The other hand is measuring the simplicity of the system. And this is both sort of conceptual simplicity and also sort of a sense of the interconnectedness and the dependencies, which is why I think perhaps the most important measure is the module interdependency measure. And I would love to know if there's other good ideas here of things you can concretely measure, because simplicity can be a very hard to grasp concept. So I want actual easy to measure metrics. So for module interdependencies, the very simple version is think about files as modules and literally look at what require statements or import statements each file has. Files importing 5 other files, it's got 5 other dependencies. And I guarantee you will find that some projects have way higher intermodule dependencies than others, and not necessarily for good reasons. I would also say there are also, I've found, indirect modular dependencies that really, I think, are valid and still count as additional dependencies. And often this is the case where module C depends on module B, and module B depends on module A, which normally you just maybe count that as 2, B on C and D and C on B and B on A. But if A gets brought into B and B almost exactly exports whatever it imported from A into C, that means that C really has an implicit dependency on A, because changes in A can break C. So thinking about modular interdependencies, I think, is super important for how easy code is to change, because you want to be able to edit one little part and not break anything else. And the more interdependencies are, the more chances are editing something way on the left is going to affect something way over on the right. At the end of the day, the goal of code quality is to change code faster. And we are looking to find ways of measuring how easy is it to understand the code and how easy is it to edit the code. And for me, I really have 2 metrics that I like. One of them I've already told you, that's the modular interdependencies, and the other one is token count. I've insinuated this before, but reducing the overall code size will make it easier to read, will make it easier to understand, make it so there's physically less to edit when you need to change things. And I like using a simple metric for all code size, which is token count. Tokens are, by definition, the smallest semantic unit of code. So they are a meaningful measure of code size, because literally each token has meaning. It conveys meaning to the compiler and affects what the output of your program is. Certainly some have more meaning than others, but they all have meaning. So it's very different from counting lines of code. Now that's a whole nother topic for another episode. So I'll leave you with that, and thank you for spending your valuable time with me. And remember, all problems are solvable with enough knowledge.